My talk is called Catch Me If You Can, and just a warning, because I know that there are a lot of very brilliant kernel devs here. This is a user line story. Going to be talking about Trace Compass, the Trace Event Logger, the Linux Trace and Landscape a bit, and just wanted to mention, this is my first tracing summit, and I am absolutely thrilled to be here. So the problem statement, we have these KPIs, and you might have these in the Grafana or something, where you have your cache hit rate, your cache miss rate, your throughput. We're looking at the effect of configuration and how it affects the performance of a system. And this is based on real-world war stories that we've had. The guilty parties have been anonymized. We want to show the hit installs and certain contention issues that we can have. So today we're going to be doing a bit of a deep dive in Trace Compass and in the Trace Event Logger. I know that's a contradictory name. The Chrome format is called the Trace Event format, and I didn't feel like calling it the Trace Event Tracer. It sounded a little too redundant, so that was the concession. And let's start off with who am I? So I am a tracing and performance enthusiast. I'm the contributor, maintainer, co-lead, product owner, give more titles to some open source tracing tools within the Eclipse Foundation. I'm also on the board of directors of the Eclipse Foundation and doing a lot of fun volunteer work on that front. I have a lot of experience inside of Ericsson diagnosing real world performance issues, and I'm thrilled to share them. And so why is Ericsson interested in this? Well, Ericsson has been contributing to open source tracing for over 15 years now, more around 20. We've been an academic partner with École Polytechnique, so you've seen Sébastien, Arnaud, Professor Lee. We have a lot of friends here. In fact, Mathieu comes from Poly. I come from Poly too. Ericsson has supported the development of Trace Compass since its inception. And it's internally used for software and hardware troubleshooting. We want to help the industry adopt the productions exchange ways of working. And, on a personal level, and anyone that's seen my YouTube page, the Trace Compass YouTube page, knows that whenever I open up a video, I will say, I'm paid by Ericsson to make the world a better place to open source, and for that I'm grateful, and I 100% mean it. So, Linux tracing landscape. There are many more solutions, and more on the diversity of solutions later on. But we have, for example, the function tracer, we have LTTng, we have perf, eBPF, we have a ton of solutions for figuring out what's going wrong in the kernel level in terms of tracing. In userspace, we have LTTng-UST, we have uprobes, uftrace, we have many things. I would argue that printf is also one, but I really think that that one is the one to avoid.
Print K.
Print K in the user space? No.
No, you could.
You could, but you're looking at that. I'm scratching this ear. And in the Java world, yeah, system console right line while we're at it. Your system out. Then there's LTTng-UST Java agent. There's the Java flight recorder, and the one we're going to be talking about is the Trace Event Logger. So in terms of viz tools, we have a plethora too. The command line goodness, perf, trace command, uftrace. We have OTel, which is really great at high-level distributed tracing. We have Perfetto, and I've said this before, I'll say it again, it's gorgeous. It's web-based, it's great for, it has a Chrome Android focus, and that makes sense considering who is sponsoring it. We have Kernel Shark, which focuses on the scheduler. And we have Trace Compass, which is trying to do a unified general purpose problem solving. And next up, we have the Trace Event Logger. I want to go a little more in detail on this. It is designed for Java tracing. It's based on JUL, and it does some things a little better than classic JUL. Like it has its own file writer, which is asynchronous, so that you can actually it's not blocking. It is UST inspired, but it is incredibly lightweight. It doesn't have a ring buffer. It doesn't have lost events. really trying just to make things easy. And there are many trade-offs, but I really like those trade-offs. And I'm just going to go a little deeper down and show you what you can do with it. And I will point here. You can do scope logging. So you have, when you write your logs, when you instrument your code, you can say, I want to measure synchronous events. And you write one line and you get an entry and an exit from a scope. This is really good because you're never going to have a dangling bit. You can have flows, and a flow is where you have one scope that asynchronously calls another one. So you can actually show the interdependency between different threads and the IPCs. You can have counters. Everyone loves counters. Line go up, manager happy. And finally, you can have lifespan analyses for long-running processes where you can have an object that you create. Let's say you're feeling generous and you give it a gigabyte of RAM. You probably want to make sure that gigabyte of RAM is released later on. And this is based on the trace event format, or the Chrome format. Now, I think this is a very important thing to bring up. The trace event format defines, if we go back, different ways to display the data that the developer is doing. And if there's one thing to take away from this talk, it's really, if you're writing trace points, you need to know how they are being consumed. You need to understand that it's not just going to dev null. It's not just because you want to check a list or something. You have to make sure that they are consumable. And tracing semantics help very much on that one. And yeah, it's basically another cool thing about the way that it's designed. Because of the nature of start-end, you can use the programming language to say, hey, the second you have a start, I guarantee there's an end. And that makes trace reading and trace display much simpler. So I'm going to talk very quickly about Trace Compass's design because a lot of people have already discussed Trace Compass. It's a modular architecture. It's got a state system and analysis engine, and it's extensible with custom views. And so what happens? You have a trace, and you make parsers for it. And the parsers convert the trace to events. Now the events go to analyses. Analyses came out before compute was a fancy word, but it's a compute. So you do your processing on it, and from that you end up from your one-dimensional events into two-dimensional states. Two-dimensional, it has a start and end time. And these states are written to a state system. And this is so much clearer here and probably for everyone on Teams. And then you can have the analysis query them back. And the states go to a data provider. The data provider will serialize them via a trace server protocol so that views can query them. These views are either in a VS Code extension or in an Eclipse plugin. And the Eclipse plugin can be made a standalone, and that standalone is very efficient. Like it takes, you can run in under 512 megs of RAM system. So that's not bad at all. I can't believe I'm saying that, but that's showing my age. And now a little note about what views we're going to be exploring today. We're going to be looking at flame charts and flame graphs. And I am thrilled to see Christophe in back, and he knows why. The naming here is, I'm going to use the word suboptimal. I'm thinking another word, but I'm going to say suboptimal. A flame graph is the aggregation of a flame chart. A flame chart is typically a stack over time. So flame chart is the industry standard. It's used in, I believe that the term is used in Perfetto. I believe the term is used also in Firefox tracing, Firefox performance analysis, and it's the call stack over time. This is a flame chart. And the flame graph is the aggregation of the flame chart where it's basically a weighted tree. And these two views, there's not one that's better than another, they're complementary. So if you want to see one in action, it's a lot prettier here than aliased here. This was an example where we compared two Git commits. The only difference between the two Git commits was that one had signing with SSH, and the other one didn't. And we can see very clearly, well, very clearly there, that we have a 30 millisecond difference. So people that are saying, oh, I don't sign my commits because it's too slow, saying that is the equivalent of signing 200 commits. So now for all those with the benefit of flash photography, there's an even better explanation here, and I'm going to strongly encourage you to watch it. It is authored by Anne, who's sitting right next to me over there. So now I'm going to talk about an example project. Now, this example project is actually a real project that has been anonymized. Now, this is standard architecture where you have a cache with many threads reading from it. Now, the cache size has been artificially constrained, and the threads can compete for access, and the performance seems really good at first glance. What do you mean really good? 99.9% cache hit rate. Pretty good. Your throughput is pretty much your disk I/O. Pretty good. But your user experience is super slow, and people are complaining. But my charts say they're good. Yeah, but in reality, it's slow. It's just that your charts are not showing the full picture. So here we did some instrumentation. We did instrumentation using the trace event logger on the code. And it's static instrumentation, which means you have to write it yourself. But it is low overhead, it's very precise, and it actually doesn't modify the timing that much of the workload. So here's the code example using the trace event logger. And I'm very excited about that because here's the original code. Everyone that doesn't love Java, keep your hands down. Perfect. And next, you have here the code. I'm sure everyone understands that. The instrumented code. You added these 3 lines here, your imports. You add a logger, and then afterwards, every time you want to add a log or a trace point, you basically put in your try, which means that it's created at the try, and when you exit the try, be it by exception or whatever, it is going to be closed. So you have a very short-lived object here. The beauty of Java is that it has this concept of Eden for short-lived objects, which means that these objects get garbage collected very efficiently and you don't need to worry about the performance overhead. It's in the microsecond level. So now, our code results on this, and I am trying to blaze through this because I hope that there are questions, but also because I think that it's time that you want some bagels. The trace reveals the cache, delays at the cache boundaries. And this is because our cache is synchronous. Our cache is synchronous because we didn't want to have, we basically put it was a locking cache because we want to make sure that you don't read this hard disk twice for the same information. So let's take a look at the results. So here's the thread that was reading from the cache. Now, this is, by the way, the VS Code, FEA, VS Codium extension. Before you were seeing some Eclipse. Here we have our individual reads. You could see here that there are many reads. All of this catching up. And then here we're reading and it's still catching up. And here, here it's blocked. This one is reading, and then this is catching up, and then this one's reading, and this is catching up. This one's reading, this is catching up. The caches became lockstep for all the threads. Now this one, now you have 2 threads waiting for it. Now here we have everything, and then we have 3 threads waiting for the cache reads. We basically have a problem where now everything is waiting for the disk. And if the cache were larger, we would have been able to finish everything a lot faster. Case in point, here's the execution time with a good cache. And then here, we can see the slower response where it was the cache size equals your dataset size minus 1. So this is pretty much the synthetic workload. We have all the data, or we have that code on GitHub if you guys want to play with it and want to see it in action. But we have here an example of where your cache shuffle means that everything gets stuck at a boundary and everything is waiting. But all your KPIs are saying that your cache hits are perfect because, well, technically they are. So, the caches, they're synchronized and you guarantee data correctness. That's good. It's very good. But in terms of performance, not so wonderful. The waiting is really affecting that. And this is one of those occasions where user-space tracing was really able to save the day. This was a real-world application where when we showed this, we were able to bring a service up and online by adding a few megabytes of cache. We were able to speed it up by a factor of 40. And this already had 200 megs of cache, so we were just a few short. If any of you are doing SRE work and you see this, please keep in mind configuration is king here. You basically are often stuck where people say, oh, it worked on my machine and it doesn't work here. That means that the configuration changed. The code is the same. So, yeah. I would like to take this moment, though, for another item that's very important for me. Everyone knows XKCD. I don't have to explain it. So I will. This is a radar plot. Basically, I wanted to just give an idea that we have two trace viewers, A and B. A is strong in some sections, B is strong in others. I think we're all, or mostly all, in open source here. We can all work together, and I want to be very clear. Ericsson wants to collaborate. We want to collaborate. We want to make the world a better place through open source, and we want to work with all of you. So, coming back, the high-level KPIs. They are good in many cases, but they can be misleading or misinterpreted. And I want to remind you all to make sure to trace, to reveal, this reveals your hidden bottlenecks. And not only that, I'm not making this presentation for you. I'm making this presentation so you have new ways to convey your message, the message across also. Because I think everyone here is already converted. But I think that we need to work together on making that message very clear. So, and cache effects must be contextualized. Basically, if our problem was simple, we wouldn't have any jobs. We actually do have context that's super important for being able to figure out what is truly going on. This was an example of how to work with Trace Compass and the Trace Event Logger. It would be just as valid to work with Perf and Perfetto. It would be just as valid to work with, I'm going to say Function Trace and Lisa because I saw that in the chat. And I'm sure that there are many other combos where it works. The techniques are the same. The songs aren't the same, but they sure rhyme. Are there any questions or comments? And I was leaving time because I wanted to have you bring up your good KPI, bad performance stories. And here's some references. Thank you. Clear as mud? I'm gonna throw one thing also. I want to start up within the Eclipse Foundation, but no admission fees necessary, a trace visualization special interest group. Would there be interest of that here to discuss like how to solve showing data to people?
How to solve what? How to solve what?
Showing data to humans. I know, I said humans. Oh, those.
No, I mean, that's a common question. I don't know if...
Yeah, I get it. Basically, it's to avoid reinventing the wheel for everyone that I want to do this.
Right. Or just make the 16th tracer view here.
Exactly. That is exactly what I want to avoid. You know, the solution to the standards problem, it's really simple. It's working together. It's not going off in your corner and doing something else.
Actually, the one thing I've been trying to do, at least from my framework of code, is not to define the final interface. Let people, I don't care if there's 50, 60 different interfaces, people like have different ideas. But I'm trying to modularize the infrastructure. So
Okay.
if you look at ftrace itself, it's always been, anyone can use the function tracer of ftrace. So the trace points can be used by anyone. The buffers can be shared if we wanted to, but we just have different ways for reasons for that. But like with trace command, what I'm doing is I'm actually working to make like trace command library that all the functionality of trace command is the library that anyone can, if they go, I want this functionality, I can use it. So I'm like building blocks. I think building blocks is a better way of doing it because sometimes, like for me, I looked at like the idea of Buffetto, the idea of Trace Compass, and I'm like, that's great, but that's not the visualization I'm looking for. But I would love to have maybe the functionality or like the internals that Trace Compass and Buffetto use to be able to build a visualization that I could understand or is easy for me.
Are you aware of the trace server for Trace Compass? The trace server for Trace Compass. It's basically...
Basically, I was actually thinking, I haven't heard of Trace Compass in a long time. I thought it was over.
Oh, yeah. I just poofed. And,
I was like, oh, Trace Compass is still around. Okay.
Yeah. So I'll just explain trace server and then get to Erica. But basically, it's it's a server. It's basically an UI list Trace Compass that you can do queries to and get your data in standardized format following the trace server protocol. And this can be pretty useful if you want to have a building block. So you have your ftrace, trace command, trace server, and then, I don't know, Jupyter Notebook or Grafana or whatever. Or just GNU plot.
Yeah, you basically do your own front end. You query that.
But you get even more data.
And like I said, that's kind of like my idea for like the scheduling stuff. I would just want something that's only scheduling. I don't want to see anything else, just a few things, and not have to like figure out to say, give me the data, and then here's the output in one nice little.
Yeah, schedule shark.
Yeah.
Yeah, I mean, Buffetto has a very similar like thing. The Python. There's Python bindings where you can do.
Yeah.
Erica.
First, Erica had her hand up first.
Yeah, I'll try and be fast because we've got 2 minutes left. But I think this is sort of a more general problem. But I think one of the big issues with shared standards amongst like large organizations is that sort of like we're discussing, there are different use cases, different interests. Like you're saying, like Buffetto is more Android Chrome based because that's their center of interest, and like other tools are better at other things because and I think that like consensus costs money. You know what I mean?
It does.
Like, consensus takes time, and especially consensus at the scale of like industries. And there's a lot of hesitation because it costs money. There's a lot of hesitation to invest in the time required for consensus, and also to relinquish the control required for consensus. So like that's why every organization has their tool, because
it's also developers going to develop.
Yeah,
in the sense I'll just do it myself.
Exactly. So like I think it's sort of there's like a lot of philosophical or shifts that need to take place before we sort of have like the groundwork required to.
Well, while I agree with exactly what you're saying, I also believe that like in this group, there is a little more gray hair than there was 10 years ago, and that we have a certain level of maturity, and that this does help a lot for realizing that these problems might not be the same, but they rhyme. And there's first Olivier, then you.
Yeah, I have a question related to, you presented the data manager, and in the latest version of 11.5 for Trace Compass, there is the mention of the data providers factories.
Yes.
We can talk about that later, but just to illustrate your example about format, I worked on a big film format, which is a new format for when you catalog books. Well, you all went to a library. When you search for a book, behind the interface, there's a format called MARC, M-A-R-C. It was invented and created by the Library of Congress. The woman who created it came from the NSA. So back in 1974, and I really encourage you to read MARC format on Wikipedia. You can find the name of that lady. But in 1974, she created that format. The French reacted, and no way we're going to take this format. The German and all the other countries tried to recreate another format. But it's been now almost 80 years, and that format is universal.
Excellent.
So, which means that every librarian doesn't have to catalog one book. Once it's done by one librarian, it's redistributed all over the world.
There you go.
Now, I was working on a new format, and then there's another new format, because now with the internet, we have linked data. But there's so much politics around those two new formats that people are still using the old one because it's working fine.
Absolutely. So, in my response is I agree. Lalit?
Yeah, so are there shared experiences that our users and we tool developers have in terms of problems that are being faced by both parties? Absolutely. I think that's 100% for sure. I think there is value in talking about those problems, and having some place where this can be discussed in general would be great. I think anything beyond that is probably like a little idealistic, I would say, mainly because there are some or even a lot of shared experiences, but there's also a lot of differences.
Absolutely.
You
And
know,
there's real world constraints that where people say you have to use X. And
it's not even about that. It's just the type of problems that we like. I don't know, like this. I've heard like the whole talks here. There's a lot of problems that people in this room are facing that like I've never even thought about. Even though I've been in tracing for 8 years, right?
Yeah.
And that's just because in Android that's just not a thing. Like in Android, CPU bottlenecks aren't a thing. We don't need billion event traces. Like our problems are just different. Like we have a billion traces, not a billion event trace, right?
Yes.
So that's our problem instead. So our emphasis is just different. And I'm not sure that you can come up with there's like one approach to tackling the massive diversity.
I'm not. There's not going to be one approach. It's just like the scheduler. I want a video game scheduler. I want a lightweight device scheduler, and I want a server scheduler. But at the same time, maybe all three of them need power awareness. And so that when you're playing video games, your hands don't catch fire, your Chromebook lasts a few hours, and the server doesn't make the whole town go out of have a brownout. So. And I know that's a bit far-fetched, I'm just trying to come up with it. But I think that there are common stories. I think that if we don't talk, we're never going to find these, and it's going to be wasteful for everyone.
Sure. That I agree.
But that's one of the reasons why we have a tracing summit.
Absolutely.
Yeah, exactly. That's what I was thinking.
Yes.
And then they all clapped.
I think we should start with an RFC and another 10 more RFC based on that one RFC.
Sure. What was the F in? Okay, yeah.
I'm sorry?
Nothing.
Oh, okay. But I would like to say that historically, like you have the Wi-Fi standard, which a bunch of companies came together and be able to develop it.
There's many standards that are like that, yes.
Yeah, but I mean, for every standard or shared piece of infrastructure, the benefit from sharing that should outweigh the cost of doing the work of standardizing something.
Yeah, and
So
we're not looking for a document, we're just looking for a community.
Sure. Good. I think we're over time into break, so let's go for the coffee break. Thank you, Matt.
Thank you.
And let's start again at, let's say 3:05, so we have our 15 minutes.